In this video, I'll talk about how to complete a truth table. At this point in your learning, you should already know how to set up a truth table and how to determine the truth value of a well-formed formula given a truth value assignment or an interpretation to the propositional letters. Provided you know how to set up a truth table and how to determine the truth value of a well-formed formula given a single interpretation, all we really need to do is put these two skills together. And so the way to start would be, what do you want to construct a truth table for? In this video, we're going to look at just trying to construct a truth table for a simple single formula. And so let's pick a formula. Our formula is going to be not P and Q. So when we look at this formula, we see that there are these operators in here. And we also see that there are two propositional letters, a P and a Q. So what we'll need to do is we will create a table and we're going to write P over here and Q over here. So we have P, Q, and we're going to just rewrite any of the propositional letters that are found in the formulas we want to construct the table for. The next thing to do is in these columns under P and Q to write every combination of truth value that can be assigned to P and Q. So let me do that. I'm going to write true, true, false, false, true, false, true, and false. Now, these four rows are all the different ways that true and false can be assigned to P and Q. What they correspond to is what's called an interpretation, and we have at each row an interpretation. An interpretation is an assignment of a truth value to these propositional letters. Now that we have every way we can assign truth values to P and Q, the next step in building out our truth table is to, for each case of P, we'll take the truth value that is interpreted with respect to P and write it underneath P in the formula. In other words, we're going to take all the information that's found under this column and just directly write it underneath P in the formula here. So we see that P is true at row 1, and so we want to write true over here under the formula. We want to do the same thing for row 2. When we get to row 3, we see that, oh right, P is false there. So let me write false. And at row 4, P is false. So I'm going to write false again. I'm just taking this information under P and writing it under P in the formula. Now we're going to do the same thing for Q here. You see that Q is true, false, true, false. And I'm going to do the same thing. I'm going to take this column and write it under Q over there. I'm going to write true because Q is true. Now at row 2, interpretation 2, Q is false. So I want to make sure I write false. Then we have true and false. So I'm going to write true and false. So what I've done here is I've taken this interpretation and I've assigned a truth value to the sub-formulas, the parts of this formula, P and Q. Now, the next step is often the most tricky for individuals who are first starting out with truth tables, and that is, what do I do next? Now, what you would do next is you would try to take these truth values that you have and use them with the valuation function associated with these operators to determine the truth value of the subformulas. In other words, you're going to write truth values underneath this negation and this sign for conjunction, and that's going to tell you, when you write it under negation, what the truth value of not P is, and when you write it under the conjunction, you're going to write it, it's going to determine what the truth value of the whole formula is. So the question that people commonly have is, well, what order do I do it in? Well, here is a trick. The trick is the order in which you compute or write down the truth value is the order in which you created the formula. So what's the order in which I would construct this formula? Well, I would start by saying that P is a wolf and Q is a wolf. That would be the first thing I would do. And then I would say, well, if P is a well-formed formula, then not P is a well-formed formula. So we have not P. And then if not P is a well-formed formula and Q is a well-formed formula, then not P and Q is a well-formed formula. So this is the order in which you would construct the formula and it's the order in which you will assign truth values to the subformulas. We would first start by assigning truth values to P and Q, which we have already done in these columns here. Then we'll move to not P, and then finally we'll use not P and Q. So with that in mind, let's go ahead and fill out the rest of this truth table. We see that we have P here, and when it's assigned a value of true, what's happening is that this truth value, we are sending it to, let's say, the negation function and saying, well, we have a formula that is true. What does the negation function do to it? Well, it says, if you give me a truth value, the value you give me is true, then I'm going to output or push out a value that's false. In other words, if P is true, then not P will be false here. When we look at row 2, we're going row by row here. Row 2, it says P is true. And so again, we're giving this negation function a value of true as input, and it's going to spit out a truth value. And the value it's going to spit out is the value of false. If you give me true, I'll give you false. If you give me false, I'm going to give you true. That's how this negation function works. So when we get to row 3, we see, okay, now we're giving this negation function the value of false, and so the output will be true. And in the case of row 4, interpretation 4, where P is false, the negation function will say that not P is true. So what we have here under this column right here is we have the truth value of not P. So we've determined not only the truth value of P and Q as well as not P, but now we are going to move on to determining the truth value of the entire formula. So what do we do here? Well, this is another question. Well, which of these truth values do I look at when I'm determining what to write under this caret? We are going to write the truth value underneath this caret to indicate the truth value of the conjunction here. And what we'll look at is the two formulas that the caret connects, the two inputs that it's taking. So we're going to look under the column under the negation as well as Q right there. So we can ignore the truth value assigned to P. What instead is going to the conjunction function is a value of false and true, the value assigned to the not P as well as the value assigned to Q. So we want to focus on those two. When we look at the conjunction function, the conjunction is only going to be true if you give it two truth values. If you give it a false and a true, or a false and a false, or a true and a false, it's going to give you false. So it's only going to be true if there are two true values given to it. So what we have here at row 1 is false and true, and so the result is going to be false. At row 2, or under interpretation 2, we have false and false, and so the result will write false underneath it. Again, the conjunction will only be true if you give it two truth values. And if we give it false and false, it's going to give us false. At row 3, though, we see that we have true and true. This not P is true, and this Q is true, and so the result will be true. And then at row 4, we have true and false, and so the result will be false. So what we have here is a formula, and we have a representation of all the different ways that this formula can be assigned a truth value for each one of these interpretations. So we'd go about reading this and saying something like, well, if we interpreted P and Q as both true, then not P and Q is going to be false here. On the other hand, if we interpreted P as false and Q as true, then not P and Q is going to be true. So this was just one quick example of how you would walk through and do a really simple truth table for a single formula. In our second example, I want to look at a different formula that's slightly more complex. Let's take a look at P and Q or P. And let's not just determine this formula's truth value for a single interpretation of the propositional letters. Let's be bold and determine its truth value for all of the interpretations. Every way we can assign truth values to P and Q. So we would write P and Q over here, and let's write the truth values underneath here. So P could be true, Q could be true, P could be true, Q could be false. We could have false and true, and then finally we can have a false and false. Okay, so these are all the different ways that we might assign truth values to these propositional letters. The next step is to fill out the truth table, to take the truth values that are assigned to the parts and use them to calculate the truth value of the entire formula. As we saw, one way to do this is simply to construct the formula and fill out the truth table in the same way we constructed the formula. So let's come over here and construct the formula, and we'll use that as our guide for fleshing out the truth table. So the way we would build this formula is to start by saying, well, every propositional letter that's found in it, Q and P, is a well-formed formula. So we'd say that P and Q are well-formed formulas. Now the next step would be to build this disjunction. We would say, since P and Q are well-formed formulas, that's established from line 1, it would follow that Q or P is a well-formed formula. And here's our last step. Since we've established that Q or P is a well-formed formula at line 2, we've established that P on its own is a well-formed formula, we can take those two formulas and put them together and put this sign for conjunction between the two, and the result is a well-formed formula. So here we'd say, since P is a well-formed formula and Q or P is a well-formed formula, it would follow that P and Q or P is a well-formed formula. So our construction here gives us a clear guide about how to complete this truth table. Let's take a look. And the first step, what we did was say P and Q are well-formed formulas. So what this would mean, if the order in which we evaluate the truth table is the same in which we constructed it, we should assign truth values to P, Q, and P, the propositional letters. So let's go ahead and do that. We would write true, true, false, false. And all I'm doing here is taking the truth value that's assigned to the P in the interpretation and writing it under the formula. I'm going to do the same thing for the second P over here. True, true, false, false. And now I'm going to do the same thing for Q, but I'm going to take the interpretation of Q in this column. Let's just put on the second column here. So we would say true in the first row, then false, true, and false. All right, so we fleshed out a lot of the table, but what's next? Again, the order in which we evaluate things is the same as the order in which we construct the formula. So what should we do here in terms of the construction? Well, we should take the truth values P and Q and use those to determine the disjunction, Q or P. And if we did that, we would take the truth value of Q and the truth value of P and use those with the function for disjunction to determine the truth value of this disjunction here. A disjunction is true provided at least one of the sides or both are true, and it's false only when both of the sides or disjuncts are false. So this would mean, I'm going to use a different color just to make things clear. This would mean that this disjunction is true in the first row. Here we have false and true. This would also be true. Here we have true and false. Remember, a disjunction is true provided at least one of the sides is true. So this would be true. And then we have false and false here. So this final row here would come out as false. Now this column under this V here tells us the truth value of this subformula Q or P. Now we're almost done. The last thing we have to do is to determine the truth value of the whole thing. And that will be indicated under this main operator, or this sign for conjunction here. Now, what do we do? Which of these many columns do we look at? Again, the way in which we constructed the formula gives us a clear guide as to how to go about assigning truth values underneath this sign for conjunction. Here it says, well, if P is a well-formed formula and Q or P is a well-formed formula, then you can take those and put them together and create a conjunction. So what we'll do is we will take P, the truth value of P here, and the truth value of Q or P in this under the sign for disjunction over here, and then look at the function for conjunction, which says that the formula will be true provided both of the sides are true. So what we're going to do is take a look at the truth value of P, truth value of Q or P, and provided both of these sides are true, then the result will be true. So let's look. We have true and true, so that will give us true. We have true and true, so that will give us true. We have false here. We're looking under P, and we have true. This will give us false, because remember, a conjunction is false if either or both of the sides are false. And then we have false and false, so this will give us false. So now we've completed this truth table, or in other words, we've determined when this formula is true for every interpretation. And our guide in this process was actually constructing the formula. Let's look at one more example. And so for this example, we'll look at not P and not Q. Now, I think it's worthwhile for you to try to fill out the table on your own. Pause the video and try to do it by yourself. And if you get stuck, again, remember the order in which you fill out this table is the same as the order in which you construct the formula. So I've started things out here by setting up the truth table and giving all of the possible interpretations to P and Q. Now I might say to myself, well, I don't know what to do next. If I did, again, another strong hint is the order of evaluation is the same as the order of construction. So I don't want to make a mistake here. So I'm going to construct the formula and then use that as my guide to filling out this table. Again, pause the video, do it yourself, and then you can kind of check your work. Okay, hopefully you paused it and you're back and ready to check your answer. I'm going to go ahead and construct this formula. What I would start by doing is saying P and Q are well-formed formulas. Then I would say, well, if Q is a well-formed formula, which I have established it is from line 1, then it would follow that not Q is a well-formed formula. Then I would say, well, since P is a well-formed formula and not Q is a well-formed formula, so since P is a well-formed formula, I've shown this from line 1 over here, and not Q is a well-formed formula, then their conjunction would be a well-formed formula. So then P and not Q is a well-formed formula. So this would also be a woof. And then if this whole thing is a well-formed formula, then I can negate the whole formula and the result will be a well-formed formula. So since P and not Q is a woof, I can negate the entire formula, not P and not Q, and the result will be a well-formed formula. Okay, so now I just have the exact way in which I should fill out the truth table. I'm just going to go step by step. Line 1 here is determine the truth values for P and Q. And so I'm going to do that. I'm going to take the information under this column, which is the interpretation of P and Q, and write it under P and Q, which are subformulas in this complex formula. So I'll say, start with this first column, true, true, false, and false. Then I'll do Q. So this would be true, false. I'm using this second column here, true and false. And so I've completed this first step. Next, what should I do? I'm looking at it, I'm not quite sure. I'm going to go back to my construction over here. It says if Q is a well-formed formula, then not Q is a well-formed formula. This is telling me take the truth value of Q and determine the truth value of not Q. All right, I'll do that over here. So since Q is a well-formed formula, since Q is here, we're going to use the truth value for this column and determine the truth value of not Q. So we're going to go each row. Well, Q is true here, so not Q would be false. Q is false here, so not Q would be true. Q is true here, so not Q would be false. And Q is false in the final row, and so not Q will be true. All right, I have completed the second step. Let's move on to step 3. Step 3 is telling me I should take P and not Q and use those to determine P and not Q. So what I'm going to do is take the truth value under P and the truth value under not Q, which is under this negation, and use those values and the function for conjunction to determine the truth value of the entire conjunction. So I'm going to look at these two columns and say, are they both true? If they are both true, then the conjunction is going to be true. But if one or both of them is false, then the conjunction is going to be false. So I have true and false here. So this would give me false since they're not both true. I have true and true. And remember, I'm looking under the sign for negation. So that would give me true. I have true or I have false and false. I almost made a mistake there. This would give me false. And then I have false and true, and this would give me false. So now I have the truth value of this conjunction, which is written under the sign for conjunction. And so I have completed step 3 here. Now finally, let's finish it off. Let's complete step 4. So step 4 says if you have a formula, which is P and not Q, and it's a well-formed formula, then you can negate it. And so what this is telling me is use the truth value of that conjunction and determine the truth value of the negation of this conjunction. So in other words, I'm going to take the truth value that is assigned to this conjunction, which determines this truth value of this whole thing under this conjunct here, and I'm going to use this sign for negation to determine the truth value of the entire formula. So I have false in the first row, and then if it's false and we're negating it, the result is true. I have true, and since we're negating the formula, the result is false. I have false. Again, we're looking under this sign for conjunction. Since we're negating it, the result is true. And I have false here, and since we're negating it, the result will be true. So I have completed step 4, and in completing step 4, I've also constructed the truth table. And so now I have a graphical or tabular representation of when this formula is true given an interpretation. Given all the different ways we can assign truth values to the letters, I can tell you if the formula is true under some specific interpretation. For all practical purposes, you are not likely to construct the formula every time you want to do a truth table. But it is an excellent way to learn how to do truth tables, and it gives you a foolproof method for if you ever get stuck about how to determine the truth values of the subformulas or how to complete the truth table.